34. Where are you, 34?
474.
Oh, right. I just wanted to do one, but that's fine. That's fine. I wanted to do another one from 3 through 28, and then a word problem.
Oh, I thought you said a word problem now.
Oh, no, I want one more and then word problems.
Oh, okay.
And yes, we're going to look at 34. We're going to look at 34. So you said 24? Okay, very good. So let's look at 24. So A equals 75. B equals 100. And angle A is 30 degrees. First thing I need to do is graph a triangle. Label correctly everything, little case, A, B, and C. Lowercase a, b, and c. So A equals 75. B is given to be 100, and the angle is given to be 30. I have to identify the case. Which case is this?
Side, angle side.
You cannot jump. So which one is it?
Side.
Yes, side, angle. You cannot jump, right? You have to start somewhere. You have to start with the side and go around the triangle without jumping, because then you may draw a different conclusion or the wrong conclusion. So I start here, side, angle. So this is the ambiguous case. Anything can happen, meaning 3 different situations. The triangle exists, I can construct it. The triangle does not exist. It's impossible to construct such a triangle. Or there are 2 triangles that fulfill all given conditions. 2 totally different. They have something in common. What will they have in common? Definitely B, and definitely 30, and definitely A. But the rest may be totally different. Good. So now I'm ready. I know what to expect. So sine 30 degrees over, yes, equals sine B over, yes, equals over C. Which proportion? I have no choice but to start with. This one, right? Because only this proportion has only one unknown. Here I'm in trouble. Good, so I will cross multiply. So 75 sine B equals 100 sine 30. What am I solving for right now? Not yet. I have to solve for, exactly. I have to solve for sine B first. Oops. 100, don't mind me. 100 sine 30 over 75. I will put in the graphing calculator. And then what will I apply to both sides? Exactly. So 100 multiplied by sine 30, close the parenthesis, divided by sine 75, close the parenthesis.
Sine 75 or just set up this 75?
I'm not sure what I'm doing. Of course, 75. I don't know why I wrote sine. And then I was going to say, is there an angle whose sine is 51? Okay, good. So is there an angle whose sine is 0.66? Of course.
Yeah.
Yes, as long as it's between, the answer is between -1 and 1, there is an angle. Good. So now all I have to do is go to inverse, second inverse, and just copy the previous answer. Don't truncate anything. So roughly, I'm okay with approximating here. Unless you want to be super exact, which is fine, you can. So B equals roughly, right. But what did we just say about this case? That I must, once I identify that I have a side-side angle, I must look at the second possibility. Second possibility. Let's look at the unit circle. So there is an angle. So this is 30, 60, right? So this is 30, 42, I'm going to say. It's not in the middle, it's a little bit less. Whose sine, this piece, is how much? Yes, the angle is 42 degrees, but this piece is 0.66 or 0.67. Awesome. I have to draw a horizontal line. I will determine a second angle with the same height, but ends in the second quadrant, with the same reference angle, which is
42.
good. And what is the second angle? And I'm going to call this B1, and I'm going to call B2. How much is the second angle with the same sine of 0.666667? Aha. So I don't know if that works or not just yet, but knowing that this is a side-side angle, I'm going to say triangle number 1 and triangle number 2. And I already copy what cannot be changed. What cannot be changed is angle A in both. There is no A1 and A2. What cannot be changed?
The two sides.
So what cannot be changed is B, which is 100. And C1 and C2. Oh, I'm sorry, A is given. Sorry, 75. I have to delete that. There is no A, little case A1 and A2. Lowercase. Okay, good. So now I claim, without knowing yet, I claim that there is an angle B1, which is 42, and you calculated B2 as 138. If that's the case, how much is C1 and how much is C2? C1, very good. And C2, so this is 168, so this is 12. Very good. So now, obviously, I will be able to determine C1 lowercase c1 and lowercase c2. So I'm going to come back here or here. It doesn't matter. So I can write sine 30 divided by 75 equals sine C1 over, I'm sorry, I do have that, of course. Sine 108 divided by C1, and the other one will be sine 30 degrees over 75 equals sine 12 degrees divided by C2. And this is the way I determine the last side. So I cross multiply. So this is C1 from here equals this times this over this. 75 times sine 108 degrees over sine 30 degrees. And from here, the same thing, C2, everything the same, but I have, instead of sine 108, sine 12. 75 sine 12 degrees over sine 30. And this case gave us what? Two possible triangles that fulfill all the given conditions, only because it was side-side angle. No other case can give us two options, two correct answers. Okay, so we had 75 times sine 108. Since I know that sine 30 degrees is 0.5, I'm just going to put 0.5. And the other one, I'm changing 108 into 12. So C1 turned out to be 143 roughly, and C2 31. Any questions? Yes.
Could you just explain real quick how you got 108 for C1?
180 minus 30 minus 42 degrees.
Okay.
It's 180. And now I think we are ready, after we saw this, and now we are ready for more problem.
When would you not end up with two triangles?
I'm sorry?
When would you not end up with two triangles?
Very good. For example, if this one is an angle that is 160.
Okay.
No, we already have 30. So 180, 150, one that could work. So when I cannot subtract from 180 and get C2, that's one possibility.
Okay.
So 180 minus 30 minus 138 gives me an angle that is negative. So if this sum, for example, exceeds 180.
Gotcha.
A second possibility is when I determine sine B for no option, for no triangle, when I get this number to be 1.3. There is no angle because sine is 1.3.
Okay.
So in that case, it will not exist at all. Nothing. Exactly. Here, I could get this to work as angles to add up to 180, but the second possibility is over 180, and I can determine the second case.
Okay.
Or it does not exist at all. Nothing. When I get sine B here as being 1.5 or
So
1.
you wouldn't have
Any triangle. And if I cannot create the second option, then I only have one option. Very good question. Thank you. Okay, so we are ready now for 34. Good. That's okay. You can. We just want to read the problem. 34. Flight of a plane. A pilot is flying over. Is that the one you chose?
Yeah.
Yes. A pilot is flying over a straight highway. He determines the angles of depression to two mileposts, 5 miles apart. We had something similar, but I'm assuming that the problem now is asking us to do something else. So we have this 32 degrees, we have this 48 degrees, and this is A, and this is B, and this is 5 miles. So we are only looking at the picture right now. He determines that the angles of depression to two mileposts 5 miles apart to be 32 degrees and 48 degrees as shown in the figure. Find the distance of the plane from point A, which we could not determine last time, and find the elevation of the plane. Very good. Good pick. So the distance to point A. So this is our first question. Let's call it X. And this is our second question. Let's call it Y. We're asked to find the distance of the plane from point A and find the elevation of the plane, which is the height. Okay. Any suggestions here?
Yeah.
Good.
You can make two right triangles, and then you can get the angles outside of 32 and 48.
Good. So do I know this angle?
Yeah, 32.
Awesome. Do I know this angle?
48.
Good. Then I know this angle.
Yeah.
How much?
58.
So, because it's 90 minus 32.
Yeah.
And do I know this?
What?
Because it's 90 minus 48, so that is
42.
good. Okay.
So it's nice. 42, sorry.
Say it again.
Sorry.
Good. So I have this distance from here till here. But I don't know this. And I don't know this. But I know that they're
You know the whole triangle.
sum. I know that their sum is 5. So this piece is A and this piece is B. And I know for now that A plus B equals 5. Agreed?
Mhm.
Good. So is there anything we can do with that? Also, if I want to determine x without even doing this, this is what we did last time. I have a way of determining and looking at this triangle in which I have all the angles. I have this side, and I want to determine x. That's even better. If you want to go that route, which I recommend.
Yeah.
Good. So what will I write?
Side. A. What was I thinking? Yeah.
Say it again. I want to involve x. That's my target. So there is no reason to go this way. So sine, very good, over,
X.
very good, equals,
Side plus 58 plus 42.
right, so it's 100, very good, over 5, very good. So sine 48 over the opposite must equal sine 100 over the opposite. That's all I need to find x. So cross multiply, so x equals 5 times sine 48 over sine 100. Do we agree with this? Last time we did pretty much the same thing, but we had to go with those two pieces, but not this time. Once we know law of sines, the whole thing is much easier. Good, so now what would you tell me to write? X is approximately, what do you get?
3.77 miles.
How much?
3.77 miles.
3.77 miles. Perfect. So I know this one, 3.77 miles. And now all I need is to look at this triangle to find y. What will you apply in this triangle to find y?
Side.
Okay, I agree with sine. Sine of
32.
very good degrees equals?
Y.
Exactly. Exactly. Cross multiply. So from here you have y equals 3.77 times sine 32. And this is a very good application of law of sines. Okay, one last section, and what is left from this is just for me to show you the graphs of cotangent, secant, and cosecant. And all the material, other than that, all the material is finished for test 2. Okay, so let's talk about law of cosines. A 100 years ago when I learned this, it wasn't called law of cosines. It was called the Pythagorean And you will probably see it in some books. The generalized Pythagorean theorem. Why generalized? Because it's applicable in any triangle. The generalized Pythagorean theorem. Okay. So in any triangle, not a right triangle, right? I denote, again, the notation is crucial. Opposite is A, opposite of B is little b, and opposite of C is little c. Okay? Assuming that angle A is 90 degrees, it's not. But for a second, let's assume that angle A is 90 degrees. Will I write A squared equals B squared plus C squared?
Yep.
If this is 90 degrees?
Yeah.
But it's not. So it's minus 2BC cosine A. If it is, how much is cosine 90 degrees? If in case A is 90 degrees, how much is cosine 90? Awesome. So this disappears. And I'm back to the Pythagorean theorem. To put the 0 that you just gave me in?
I guess I get 2BC.
Okay, so that's how you have to subtract. So I was saying if, just to make it easier and see how, if you remember this, if this is 90 degrees, I will write A squared equals B squared plus C squared. But it's not 90 degrees. Then I have to write minus 2BC cosine A. And then I said, okay, what if A is 0? What if A is 90 degrees? Then cosine, you said, cosine is 0, so then I'm back to the Pythagorean theorem. Now, can anyone tell us what will this look like if I have B squared? Because there are 3 forms for any angle can go around. So B squared will be exactly minus 2AC cosine B. Okay, can anyone give us the last one? What if C squared is what we are interested in? It has to be AB. That's it. This is the generalized Pythagorean theorem, or as we like to call it now, law of cosines. So let's start with anything you want on page 480. And we will have more problems. More problems so you can appreciate law of sines and law of cosines. But let's first start with, let's pick a problem in which the sides are given, or the angles are given. It doesn't matter. You pick.
About 3 through 12.
I'm looking at 3 through 36 on page 480. Let's start with 18, and then you can choose the next one. Let's say A equals 65, C equals 50, and angle C is 52 degrees. The same question here. Solve the triangle ABC. If we're given all angles, we will have to use law of sines first. Because if I don't have any sides, I'll have 2 variables in each. I'll have 3 variables actually in each equation. So let's see what we have here. Here's A, B, and C. The opposite of A is 65. The opposite of B is just B. The opposite of C is 50. And angle C is 52 degrees. So we're asked to solve this triangle. Okay. Let's see if this works. Don't write anything just yet. If I want to determine this, I need cosine B. I have A and I have C. I have A and C, but I don't have cosine B. So I cannot apply law of cosines right now. Okay, let's see if I want to determine this angle. If I want to determine the angle A, I do have A, I do have C, but I don't have B. So I don't have the angle and I don't have B. So two variables. So I can't, in this situation, I cannot apply law of cosines, right? So if I want, okay, can I use for this? Okay, so let's for C. I don't have B, and I could determine B because I have A and I have C. So for this I could.
Yes.
Or I find one more angle using law of sines. And then I can apply law of cosines. Or, since we are here, okay, that's fine. So let's do this. Let's do this. So C squared, 50 squared, equals A squared, which is 65 squared, plus B squared, which is unknown, minus 2 times A times B. 2 times 65 is 130 B times cosine C. I would have not gone this route. I will with you, but here's why I would have not done this. Only because now I have to solve a quadratic equation with a middle coefficient that is 130 times cosine 52 degrees. I would not have done this. I'm not saying it's difficult. I'm saying too much work. I would have used law of sines to determine one more angle, and then I would have been in business not having to do this. But we're here, let's do it. So then this is B squared minus 130 times cosine 52 degrees. I can keep it as is, but then it will be more difficult to put it in the graphing calculator in the quadratic formula because I have no other way. So let's do 130 multiplied by cosine 52. I guess I need this number. So let's say it's 80. So minus, it's not exactly 80, but I'm making my life easier. Okay, and then I have 65 squared minus 50 squared. 65 squared minus 50 squared, because I have, so it's 1725. So plus 1725 equals 0. I had to do all these preliminary calculations instead of simply using law of sines to find another angle. You can say, well, it's not that simple. This is easier. Fine. So B squared, this is minus 80B. I subtracted 65 squared minus 50 squared to get this. And now I have to put these numbers in the quadratic formula. Negative B plus or minus the square root of B squared minus 4 times 1 times 1725 over 2A, which is 2. Is this okay? So with the graphing calculator, put parentheses around the top, parentheses inside the square root. So parentheses around the top, 80 plus the square root of 80 squared minus 4 multiplied by 1725. 1725. 2, 5. Close the parenthesis, get outside of the square root, close the parenthesis, and then divide by 2. Unless I typed in something wrongly, what do we conclude about the triangle?
Doesn't exist.
Exactly. No solutions.
Alright, so now you decide.
Exactly. That was exactly what I was going to say. So with this, it appears there is no solution. Okay? So now let's write law of sines on this. So I have sine A over 65 equals sine B over little b equals sine 52 degrees over 50. Which is the proportion that has only one variable that I can solve? Yes, right. So I have sine A equals 65 multiplied by sine 52 degrees over 50. If the first calculation was correct, unless I put in something else in there, but I'm assuming you got the same answer, right?
Yeah.
Okay, perfect. Then this number should be what? Before I calculate this, if there is no solution, what should this number be?
More than one, outside of -1 over 1.
Exactly, more than 1. Exactly. So let's calculate. So 65 multiplied by sine 52.
1.02.
Exactly. And multiply by 50. Once I see this, there's no discussion. I didn't have to find the quadratic equation. I didn't have to put in the quadratic formula. So that's why, depending on the problem, I cannot give a recipe that works in all situations. But since this number is 1.02, let's see what happens when I put in sine inverse of this number. As expected, it tells me to wake up. Good, so let's look at 32. In 32, we're asked to find the area of this triangle. So we are given A equals 11, B equals 100, C equals 101. But I'm also going to ask, before we find the area, because I have not shown you how to find the area, we have two different formulas for the area of a triangle. This will be the third one that I'll show you right now. But first I want to solve the triangle. Here's a triangle. A, B, C. Little a, 11. Little b, 100. Little c, 101. In order to solve the triangle, what am I trying to find?
Angles.
Of course. So let's say I want to start with angle A. For sure, I cannot apply law of sines. Because all the angles are at the top, I will have 3 variables. Right? In each proportion, 2 variables I can solve. So I have to use the law of cosines here. Can anyone dictate law of cosines? A squared equals.
B squared plus C squared
Yes, and this will be the Pythagorean theorem as we know it.
minus
2bc
cosine.
cosine A.
Is it always times whenever you're adding?
Yes.
C, so
Yes, minus 2bc cosine A. Good. So I have 11 squared. I have 100 squared. I have 101 squared. I have minus 2 times 100 times 101 times cosine A. Do not multiply anything. Do not perform any arithmetic calculations. Let me show you how to address this. This is a negative term. I will move it here. And I will move 11 to this side. So 2 times 100 times 101 times cosine A equals 100 squared plus 101 squared minus 11 squared. What do you think I'm going to do next? I'm going to solve for... Exactly. Thank you. And put the whole thing at once in the calculator. Do not chop it up. You're going to introduce a lot of error in the problem. Parentheses are on the top. Parentheses are on the bottom. So parentheses. In 100 squared plus 101 squared minus 11 squared. Close the parenthesis and divide by parentheses, please. 2 multiplied by 100 and multiplied by 101. This is 0.9940. I go to second and cosine and copy the previous answer. The whole thing. Don't truncate, don't. So my calculator is in degrees. So how much is A? 6 degrees. I'm fine with 6 degrees. So we got 0.9940 approximately, 0.9940 or 41 even. And then we got A equals 6 degrees. So I go back and this is 6 degrees. I can apply law of cosines again to determine any of these two and then subtract from 180. Which one would you like to do? Or, once I have an angle, I can go back to law of sines. Whatever you want. This is the recommended way to solve in one step for cosine A. There's no need to square this, subtract, and then divide by a negative number and multiply these. There is no need. One step, everything together. So would you like to find another angle? Say it again.
So
Yes.
would it be better just to manipulate the equation in advance for what we're trying to solve? And just plug
You
it
mean
in?
before you plug them in?
Yeah.
That's fine. Absolutely. So you can, from the beginning, from here, you can say cosine A, right, equals b squared plus c squared minus a squared over 2bc. That's fine. Absolutely. So you want to find b or c with law of sines or law of cosines? Since I should have said, sorry, my apologies, what case is this?
It was 3 sides.
Side, side, side. It's not the ambiguous case, which means I can build the triangle or the triangle does not exist because it's side, side, side. It's not side, side angle. Good. So you want law of sines or law of cosines? Okay. Okay, very good. So which one do you would like to determine? Angle B?
Yeah.
Okay. If that's the case, then it's b squared equals a squared plus c squared minus 2ac multiplied by cosine b. And yes, as Paul said, I'm very happy he said that, not me. You move this term here, you move this term here before you plug it in. So 2ac cosine b equals a squared plus c squared minus b squared. So then cosine b equals a squared plus c squared minus b squared divided by 2ac. The second one is c, sorry. Divided by 2ac. And now you can plug them in. So then cosine b, okay, for a squared, 11 squared plus 101 squared minus 100 squared divided by 2 times A and times C, which is 101. So I plug it in. Don't forget parentheses around the top. So 11 squared plus 101 squared minus 100 squared, close the parenthesis and divide in parentheses by 2 times 11 times 101. You must have parentheses around the top and parentheses around the bottom. So I got 0.1449. This is law of cosines. So I'm looking for cosine inverse. So it's roughly 82 degrees. So this was approximately 0.1449. So then B equals approximately 82 degrees. So now I do have all sides and all angles, because angle B is 82 degrees. So then 6 plus 82 is 88. And when I subtract 180 minus 88, I get and that's law of cosines. We'd like to look at the cable car. I know we have 5 minutes left. If we finish it now, fine. If not, we'll finish it on Wednesday. So what I still owe you for Wednesday is to bring the previous test so we can go over it and review, and to show you a cotangent, the graph of cotangent, secant, and cosecant. Although I will not test you on these three. Thank you. Thank you. Okay, so I think next week. So I think I am in the stage in which I write down and I forget where I wrote it down. I'm approaching that stage. Okay, so we are given three sides. We are determining the lowercase s, which is semi-perimeter. Yep. Which equals A plus B plus C divided by 2. And then a famous mathematician showed that the area of a triangle can be determined if you have all three sides. Okay? So I'll review all those three methods with you in the following way. S minus A, S minus B. This is not 5, but it's S. Sorry. And S minus C. So let me review the three possibilities for the area of a triangle. We know three different possibilities. So area of a triangle. Base and height are given. Two sides and the angle in between them. And here, all three sides. So we have three different formulas. The area of the triangle, if the base and the height are given, 1/2 base times height. The area of the triangle, when we know we've done that a long time ago, two sides and the angle in between. A times B times sine C divided by 2. And all three sides, the area of the triangle is, but I have to calculate the semi-perimeter. If all three sides are given, I have S, S minus A, S minus B, S minus C. A times B times sine C over 2. This is the formula that we looked at a while back.
And it says two sides and the angle between them?
In between them, yes. Yes, the angle in between. Good. So here we were given these three sides. I have to find this semi-perimeter first, which is 101 plus 100 plus 11 divided by 2. How much will that be? So this is 201 to 12. Am I correct? Don't trust my numbers. So 106. Am I correct with the semi-perimeter?
Yeah, that's what it was.
Good. So now the area of the triangle will be the square root of 106. 106 minus 101 times 106 minus 100 times 106 minus 11. So the area of the triangle will be the square root of 106 multiplied by 5, multiplied by 6, and multiplied by 95. I'll put in the graphing calculator, multiply all these, put everything in parentheses, mandatory. So I have the square root of, in parentheses, 106 multiplied by 5 times 6 is 30. And multiply by 95. Close the parenthesis. And this is the area of this triangle. 549.64, approximately. 549.64. Whatever units squared.